Good morning, everyone. So let's begin today's session. Today we are going to discuss about second normal form. In the last session, we have discussed first normal form. So what is first normal form? Basically, whenever we try to design a good database, what we do is we dump all the attributes those are identified in a single table. So initially, we are having unnormalized relation. And what we do as the first step is we seek for the attributes having repeated groups. Once we identify such attributes, we say that these attributes are having non-atomic domain. So the first basic normal form that we would like to impose upon on unnormalized relation is the first. So we have defined 1NF, and the definition of 1NF says that if every attribute or if domain of every attribute in the relation is atomic, then we say that the relation is in 1NF. In other words, we say that if each row and column intersection of each row and each column of the table is having a single value, then we say that our relation is in 1NF. We have seen the example in the last class, right? And we have tried to convert unnormalized relation into 1NF. In the last class, we have seen two approaches to convert unnormalized relation into first normal form, right? Today, we are going to discuss second normal form. So the basic requirement of the database is, in our database schema, every relation must be in 1NF. Further, we go on imposing more stringent rules so that we can have good database. In the last class, we also defined second normal form, and we have seen some properties of second normal form. So second normal form is based on the concept of full and partial functional dependencies. So we have seen earlier these kinds of dependencies. We are having a functional dependency of the form, say X determines Y. So what is X? X is set of attributes, and also Y is another set of attributes. And X is determining Y, and that is the functional dependency. So if we are having a proper subset of X such that W, and if W also determines Y, then Y is not fully dependent on X, but Y is partially dependent on X. So this is what we mean by partial dependency. And what about full functional dependency? If there is no proper subset of X, W, which also determines Y, then we say that it is full functional dependency. So second normal form is basically based upon these concepts of full functional dependency and partial functional dependency. So obviously, if we have a relation wherein the primary key composed of two or more attributes. I'll repeat. If we are having a relation wherein primary key is composed of two or more attributes, then there is a chance that we may find a proper subset of primary key, right? And that proper subset may also determine the right hand side of the functional dependency or few attributes of the relation. So second normal form applies to the relations with composite keys or the relations with a primary key that comprises of two or more attributes. If the relation is having a primary key of a single attribute, then obviously we may say that that relation is in 2NF, at least in 2NF. So we are assuming now that every relation that we are talking about is already in 1NF. And if a relation is in 1NF and having a primary key comprising of a single attribute, then obviously that relation must be in 2NF. But if the primary key composed of two or more attributes, then obviously there is a chance that we are having some partial dependencies in that relation. And there is a scope now to go for further higher form, that is 2NF, right? So if a relation is not in 2NF, obviously it may suffer from the anomalies, and we would like to avoid the anomalies, right? So we have seen this definition of second normal form. So how second normal form is being defined? A relation R on relation schema capital R is in second normal form if and only if it is in 1NF. So the mandatory condition for second normal form is, the first condition is it should be in 1NF, and every non-primary key attribute must be fully dependent on the primary key. I'll repeat, the second important condition is every non-primary key attribute is fully dependent on the primary key. And if all the relations of the database are in 2NF, the database is said to be in 2NF. So in our database schema, usually we are having more than one relations. So when we are going to say that database schema is in 2NF, if every relation in our database schema is in 2NF, then we say that the entire database is in 2NF, right? And what is the definition of second normal form? It should be in 1NF, and the second important condition is every non-primary key attribute must be fully dependent on the primary key. So I hope you must have understood now the definition of second normal form, right? So let us proceed now with examples. So in the last class, we had a client rental relation in 1NF. So in the last class, we had the unnormalized form of a relation and we converted that relation in 1NF. right? So after flattening the table, after applying the first approach of 1NF, we have got this client rental relation, right? So if you look at this particular relation, what you can observe is there are now no repeating groups under every attribute, right? So every attribute is now having atomic domain. Or in other words, if you look at this client rental relation, intersection of each row and each column contains a single value, right? And that is why we are saying that this particular relation is in 1NF. Now, once we are having the relation in 1NF, the next step is we need to list out the functional dependencies now for this relation. So we have listed out here the functional dependencies. So what are those functional dependencies? See here. We have found out for this relation that client number property number is the primary key. What is the primary key? Client number property number. So these two attributes are actually determining all other attributes in our relation. And that is why we are saying that client number property number is our primary key that determines all other attributes in this relation. Now, if we look at this particular table, we can identify few more dependencies. Say for example, client number determines client name. See here, if I am having say client number CR76, then I am having the same value for client name, that is John K. I am having one more tuple here with the same client number CR76. So for that tuple also, I am having the same name for client name. Right? So we may come up with this dependency, client number determining client name. Right? Similarly, property number determines property address, rent, owner number and owner name. Are you getting me? Property number determines property address, rent, owner number, owner name. So if I repeat the property number, see here, PG4 gets repeated. So for these two tuples, wherein we are having same property number, the values of address, rent, owner number, owner name are same. Property address, rent, owner number, owner name. So we may come up with this functional dependency. Similarly, we are having owner number determining owner name. So if owner number is same, then we must have owner name which is also same. So owner number actually determines owner name. So that is one more functional dependency that we may have. Further, we have identified two more candidate keys. So client number, rent start determining all attributes. Property number, rent start also determines all the attributes. So these are the additional candidate keys, those we may find. But now we are, as far as second normal form is considered, we are bothered about the partial dependencies. Right? And we have identified here two partial dependencies. This and this. Client number determines C name and property number determining P address, rent, owner number, owner name. So why we are saying that these two are the partial dependencies? See, the primary key is client number, property number. Right? primary key is client number property number, meaning client number property number is determining all other attributes in the database. Do you agree with me? Yes? Do you agree with me?
Yes, ma'am.
But so this is my primary key, client number, property number. But if we only consider client number, so these two attributes are determining all remaining attributes of my table. And that is why we are saying that client number, property number is my primary key. But what happens is, if we look at this attribute client name, whether client name is dependent upon property number. Yes. Whether client name is dependent upon property number. Yes, anybody? See, client number property number is determining client name. Why? Because client number property number is my primary key. And this primary key is determining all the attributes. Right? So obviously, client number property number is determining client name. Right? But my question is whether client name is dependent upon property number. See here, if I am having this property number PG4, then for this tuple with property number PG4, I am having client name as John K. One more entry I am having here for property number PG4, same property number. But here I am having some different client. So in fact, client name is dependent upon client number. So client number, property number, though it is my primary key, the proper subset of this primary key, that is client number, also determines client name. What we are trying to do? See, we have identified that client number, property number is the primary key. What we mean by primary key? Primary key is the key that determines all other attributes in our table. Do you agree with me?
Yes, ma'am.
So, if client number, property number is my primary key, it must determine client name. Right?
Yes.
Because it is primary key. And primary key is determining all the attributes. Right? So, client number, property number must determine client name. So, we are having this as the valid functional dependency, right? But what I'm saying is, if I look at this functional dependency, left-hand side of the functional dependency, this left-hand side comprises of more than one attributes. So obviously, I may come up with the proper subset of this left-hand side. And I'm having the proper subsets as client number, property number. Right? And this proper subset, that is client number, is also able to determine client name. So client name is partially dependent on this primary key. Are you getting me?
Yes, ma'am.
I do not require property number to determine client name. Client number is sufficient to determine client name. Do you agree with me?
Yes.
So that is why we are saying that this is a partial dependency, because the proper subset of this left hand side can also determines this right hand side of the functional dependency. Right? So we are having here this partial dependency, client number determining client name. Similarly, if we want to determine property address, rent of the property, owner number, owner name, then these attributes are dependent on property number only. To identify property address, we do not require client number. It is not dependent on client number. Property address depends upon property number. Rent depends upon property number. Who is the owner of that property depends upon property number. Owner name depends on property number. Right? So, client number is not required to identify these attributes. And that is why the proper subset of this CNO, PNO, that is the client number, property number, the proper subset of this, that is property number, is enough to determine property address, rent, owner number and owner name. And that is why we are saying this is also my partial dependency. Is that correct? Are you getting me?
Yes.
So, once we have identified that there are certain partial dependencies, then with the help of these partial dependencies, now we are going to convert this table in 1NF into 2NF. Right? Because we have gone through the definition of second normal form. So what definition says? The relation must be in 1NF and every non-primary key attribute is fully dependent on primary key. Every non-primary key attribute is fully dependent on the primary key. But here, my primary key is client number, property number, right? And this client name is non-primary key attribute. But it is not fully dependent on my primary key, but it is partially dependent. Similarly, property address, rent, owner number, owner name, these are non-primary key attributes and those are not fully dependent on my primary key, that is client number, property number. But these are partially dependent on my primary key. Right? So as we have identified these partial dependencies, to come up with 2NF, we need to remove those partial dependencies. And if we remove the partial dependencies from the relation, then we may come up with the second normal form of the relation. Now, how to remove these partial dependencies? That is a question, right? So we are going to address now this issue. I hope you must have understood whatever we are discussing. So we are going to address now how to remove the partial dependencies, right? And once we remove the partial dependencies, we come up with second normal form. So this is the pictorial presentation of the functional dependencies, those we have identified. So we are having a relation in 1NF and whatever functional dependencies, those we have identified, those are pictorially shown in this slide, right? So it is the same thing. So now, once we have identified the dependencies and specifically the partial dependencies in our relation, what we need to do is we need to convert the relation in 1NF into the relation which is in 2NF. So as I stated, if partial dependencies exist, the relation is not in 2NF, and we would like to transform now this client rental relation in 2NF. So what we need to do is we need to decompose this relation. What we mean by decomposing the relation? Right now, we are having a single relation. So decomposing a relation means by making use of these partial dependencies, we need to split our table into multiple tables, right? So we are going to decompose the relation such that non-primary key attributes are removed along with a copy of the part of primary key on which they are fully functionally dependent. What does this mean? In simple words, what we are going to do is, once we have identified the partial dependencies, what we are going to do is, we are going to decompose this relation such that we'll be having or we'll be using this partial dependency and we'll be creating a table, separate table with these attributes, right? Similarly, we are going to convert or we are going to create one more table as we are having two partial dependencies. For this partial dependency, we'll be having separate table. For this partial dependency, we'll be having a separate table, right? So, decomposition of this relation, meaning we are going to split this table into multiple tables. And as we are talking about second normal form, we are considering the partial dependencies to decompose our relation. So in a straightforward manner, what we are going to do is, for every partial dependency, we will be having a separate table. So client name depends on client number. So we'll be having a separate table for that. Property number is determining property address, rent, owner number, owner name, right? So we'll be having a separate table for that. What next? For partial dependencies, for every partial dependency, we'll be having a separate table, and all remaining attributes along with the primary key will go in one more table. So for this client rental relation, we will be having these three tables now. We are having initially this one relation in 1NF. We used partial dependencies to come up with two separate tables, right? So client number, client name will go in one table. Property number, property address, rent, owner number, owner name, which is other partial dependency. So these attributes will go in other table. So we have formed client table, property owner table, and what remains? These attributes are covered under these two tables. So which attributes are remained now? Rent start and rent finish, right? So we are going to create now another table having these two attributes along with the primary key. So what is the primary key? Client number, property number is the primary key. So we'll be forming a third table now, having the attributes client number, property number, rent start and rent finish. So this is how our relation in 1NF is being decomposed into these three relations. And if we try to find out whether these three relations are in 2NF, then we can easily identify that now these relations are in 3NF, in 2NF. How? If we look at these three individual relations now, right? What are the conditions for the relation in 2NF? The very first condition is the relation must be in 1NF. So we can identify that each of these relations is in 1NF. Right? Because all the attributes here are having atomic domains. Do you agree with me? Yes?
Yes, ma'am.
So all these three relations are now in 1NF. And the second condition, what our second condition says? All non-primary key attributes must be fully dependent on the primary key. So for this relation, our primary key is client number, right? So non-primary key for client relation is CNAME, and CNAME is dependent on client number, right? In fact, if the primary key comprises of single attribute, then obviously that relation always in 2NF. So even we do not need to check for it. If the primary key comprises of a single attribute, then that must be in 2NF. Okay, so property owner, once again we are having a single attribute as primary key. So obviously this relation is also in 2NF. Right? So what about this third relation in our decomposition, that is rental relation? So we need to check now whether this is in 2NF. So the condition number 2 says that every non-primary key attribute must be fully dependent on our primary key. So what is the primary key for this rental relation? Primary key for rental relation is client number, property number. So it is a composite primary key having two attributes. So what we need to check is whether rent start is fully dependent on this primary key. Also, what we need to check whether this attribute rent finish is fully dependent on this primary key. So if we look at this rent start, then rent start is fully dependent on client number, property number. Why? See, if we consider only client number, then client number is repeated here, CR76, CR76, right? So if we consider only client number as the primary key, then whether client number only determining rent start? No. Why? Because for these two tuples having same client number, we are having different values for rent start. So rent start do not depend only on client number. Similarly, this rent finish do not depend only on client number. Also, these two attributes do not depend only on property number. So, to identify these two attributes, this primary key, composite primary key is required. So these two attributes, rent start and rent finish, are now fully dependent upon this primary key. And that is why we say that this relation is also in 2NF. Got it? If you have any doubts, please let me know.